The government has quite a focus at the moment, largely led by public concern, but on improving freshwater health. There's hardly a New Zealander probably that hasn't heard something in the news about the degradation of waterways, and particularly from a human health, a swimmability point of view. So most New Zealanders are aware of the need for us in this agricultural nation to improve waterways.
We talk to a lot of farmers and many of them are like, I want to do something, what do I do? How do I go about doing this? And so being able to go to them and say, well, here's some simple things that you could actually do yourself, which will all help improve the situation.
Living Water very quickly realised that in order to find solutions, you need to be very clear about what the problems are. And so we partnered up with Canterbury University, with the CAREX team at the university, and they are helping us to establish what the problems are, whether it's contaminants in the water, whether it's nutrients, whether it's sediment, or indeed something else that we should focus on. And so by monitoring over a year or more now, we've been able to establish what some of the key issues are, and in particular we've discovered that sediment is quite a significant issue for this waterway and probably many others in New Zealand too.
So you may be wondering, why should you care about sediment? Well, if you think about the biological nature of the stream, there's the bugs and the invertebrates that live in the cobbles or in the stones along the base of the stream. Now what happens when sediment flows in is that it fills the space in between those stones, and that means that the invertebrates, the bugs, they lose their home and they lose their food. And when they disappear, then the fish, the whitebait, the eels, then they lose their food as well, and so they leave, creating a dead stream. Now that doesn't sound like an issue, but these smaller streams in a farming context, when they flow into a bigger stream, which then flows into a bigger stream, then you get to the rivers that you want to use for swimming, but then they are now polluted by the contaminants coming off these smaller farmland streams. A financial benefit could be through the solution of building a sediment trap. You can trap the sediment in a fixed location instead of maintaining hundreds of metres downstream, saving you money in the long run.
Sediment Trap's just one of the tools in our toolbox to deal with some of the issues in the agricultural landscape. They can be utilised in a range of different places in sort of an ephemeral waterway, for example, or on these more permanent waterways. So they can be used at a farm scale or on a catchment scale. They could be used by a local authority, such as the council that we're working closely with, or even a regional council, for example, across a whole region. It is a case of horses for courses, and we see these as a useful tool where we could trap the sediment before it makes its way downstream.
As part of CAREX, the role we serve is to investigate where the sediment's coming from, where the sediment is actually moving through the system and when it is moving through the system, because obviously a flood is going to carry potentially more sediment than day to day. So to estimate that, we've used a combination of sediment tiles to measure the stuff moving along the ground. We've used sediment pottles to estimate the stuff moving through the water column, and then we've used stage height loggers to measure actually how the water level is changing over the year. And by combining all of that, we get an estimate of how much is moving, what size the sediment is, so is it large and actually drops out quite fast or travels along the bottom, or is it fine material that's travelling through the system in the water column, and the finer the material, the larger the sediment trap needs to be. And so what we've found is that it's actually largely fine silt moving through the system, and so we've created a table where a farmer, a stakeholder, any person really, is able to go to a stream and say it's this wide, it's 1.5 metres wide, it's flowing at 0.2 metres per second, but that can be estimated just as simply throwing a stick into the water and measuring how long it takes to travel 10 metres, 5 metres, just simple. From those two measurements, they are able to say, well, actually, to capture 50 to 60% of the sediment, it needs to be 7 metres long and 0.5 metre deep. For this table, we've gone for shallower but longer, and that's because the systems that we work in, being roadside or in farms, we want to limit the effect on the farmer themselves. So we've not changed the width, so the width fits within the system, and we've limited the depth so that there's less risk of bank collapse by digging deeper. And so that way the farmer should be able to implement this plant along the side and not change how they manage the surrounding area that much.
Okay, so this trap is 12 metres long and about 0.9 of a metre deep. So all we're doing is digging a pool and we're getting the water velocity to decrease as it goes into the pool. And so you can see here that the water is moving quite quickly. And as it moves at a higher speed, the larger particles start to drop out. And so in this area here, we've got quite a bit of sand occurring. So sand is a heavier, larger particle than the very, very fine silt and mud that we get towards the bottom of the trap. And the trap here is actually quite deep because we've got large substrate. And if I poke my stick in here, it only goes down about 5 centimetres. So this trap's been here for about 9 months or so. And we've got very, very fine sand. Then as we move down into the trap, as we get deeper down into the sediment trap, the water velocities have slowed down a lot. And now you perhaps can see that we've got this darker brown material, which is much, much more finer sort of substrate, finer particles. And they've dropped out because the water velocity's got less and less as we go into this pool. And then as we move downstream towards the end of the trap, we've got a lot more sediment accumulating. So the top of the trap is filling in slowly, but the bottom end of the trap, where the water speed is reduced enormously, is now starting to fill up. And this trap's getting fuller and fuller of fine sediment. If we poke a stick down here, wow, you can see now I've gone nearly 40 centimetres of depth here as compared to a few 5 centimetres or so at the top. So the trap's filling out of this end. So this is probably coming to the stage where we would now think about emptying out this trap, getting the landowner to come and clean it out so that its efficiency continues over a long period. So that's one of the things about sediment traps, is they do require maintenance. But what we've done here, in a 12-metre reach, we've taken out a whole bunch of sediment out of the system, which is now not moving downstream. If we clear this out and take it away, then over time we can actually reduce the amount of sediment that's moving down the system, because we're collecting it in this trap and then removing it. How quickly these traps fill in depends on how much sediment's moving down the system. So they're going to vary from one waterway to another. In other places we've had these traps cleared, and literally someone with a digger can clear them in 20 minutes. But how quickly or how frequently you need to clear it is something that you're going to get through experience. Part of the issue, I guess, is where you're going to put the stuff that's come out of the sediment trap. If your farmer or landowner has paddocks around which have hollows in them and those sort of things, they can use this to fill up the low points in their ground, so they won't necessarily have to cart it great distances. Our group at the University of Canterbury and Living Water is about trying to come up with solutions, trying to come up with ways in which we can help farmers, landowners, water management agencies actually do something on the ground about fixing some of these issues. A lot of the major solutions are going to be through changes in farm management practices, but beyond that, there's other stuff that we can do. It's really important because the issues that we're seeing here are being faced up and down the country. So in lowland agricultural areas, whether you're in the top of the North Island or the bottom of the South Island, they're all experiencing these same sort of issues and struggling with how do they actually do something about it. A lot of people would probably realise that the face of our country is changing. And so if you're aware of what's going on with public opinion, with government policies, with regional council policies, there is a move for change. We need to start, we need to do something about it, and we need to accept that we're going on a journey here. And as many people as we can get on that journey, the better.